Hello everybody, my name is Sergio. Today I will be demonstrating how you can effectively prove the Archimedes principle. So here I have two glass containers. Well, one of them is plastic, but one of them is glass, which is the one that I will be weighing. So here I have $2 worth of coins. As you guys can see, I have put tape around them, which this way we're gonna ignore, which due to my skull, that doesn't weigh more than any decimal points after. So first I'm gonna start out by weighting the glass container. As you guys can see, it's around 875 grams, so 873, which I had last recorded. And previous one I had recorded that one is the one that changes, so I left it blank so I could put the one that I will be using. So now I'm gonna start with the procedure. So I will put this glass right here in the middle, and then I'm gonna fill it up all the way to the brim with water. We know that with this principle, buoyant force equals to the water displaced by the object. So here I'm just trying to make sure that it's all the way to the brim, so there's no. There we go. And I will be dropping in the coins. You guys see how it displays kind of water on the side? So that's the water that we're gonna be wanting to weight. So here I will be carefully trying to take this off without trying to drop any more water in there. We're gonna use this water later on. So here I'm gonna weight this water. You see it's not a lot since the object is not that heavy. I'll be weighing here. So we do have a change. So right here we have mass of the water, which I have recorded to be 878. Simple math, we do 878 minus 874, which gives us 4 grams. I have also pre-recorded the mass of the coins, which is 45 grams. And we know based on the principle that, as you guys see right here, the coins have sank to all the way to the bottom. And that's because the buoyant force wasn't strong enough, wasn't stronger than the weight of the object. So that's why they sank. So I will be showing you guys another different method to see how the buoyant force of a different object will make it float. Since we know that heavy objects, you see I have this cap right here that we'll be using for it to float. Since we know that ships, big metal ships, are able to float, and that's because of the water they're able to displace. So you guys see how this one's able to displace water. So right here it's safe to assume that the buoyant force is stronger than the weight of the object. So right here this cap is floating around. I also want to remark that the density of these two objects are a bit different, since we know that an object will float or will sink due to the density of the material of it. So we know that the coins right here, it's safe to assume that they sank because the density was greater than that of water, which we know it's 1.00 grams per milliliter. And this one where it's safe to assume that it's less than that, so that's why it's floating. So yeah guys, that's it. That's all I have for today. Thank you.